Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for doing this for us. Now let's look at our activity for today. We'll continue with set and set operations. Today we are on part 5 of this topic. And on part 5, we'll be learning to describe and identify various regions of the Venn diagram. In this case, we'll be focusing on 3 intersecting sets. At this point, I believe we can start our activity for the day. We would start by looking at 3 intersecting sets. This Venn diagram shows 3 intersecting sets: set A, set B, and set C. These sets are also subsets of the universal set. So as you can see, they have been drawn inside the universal set, the rectangle. We will be identifying and shading some regions within this Venn diagram. Let's look at the first example. For our first example, we will be shading the region A. So we first have our Venn diagram showing our 3 intersecting sets within our universal set. Now let's shade our region A. Our region A is the entire set A. So what we will do is we will shade the entire set A. So this is our region A. Let's look at our next example. For this example, we'll be looking at region B, which is the set B. First, we have our Venn diagram showing our 3 intersecting sets within our universal set. This is the region representing B, or set B. Let's look at the next example. For this example, we'll be looking at the region C, or the set C. So we first have our Venn diagram of 3 intersecting sets, and this is our region C, or the set C. Let's look at the next example. For this example, we'll be looking at the region A intersection B. We will first have to show our Venn diagram of 3 intersecting sets. The region A intersection B is the region where the set A and the set B meet. So this is the region A intersection B, the area where the set A and the set B meet. Let's look at the next example. Next, we'll be looking at the region B intersection C. First, we'll show our Venn diagram. The region B intersection C is the region where the set B and the set C meet. So this is the region B intersection C, the place where the set B and the set C meet. Let's look at the next example. Let's look at the region A intersection C. We will first show our Venn diagram of three intersecting sets. The region A intersection C is the region where the set A and the set C meet. This is the region where the set A and the set C meet. So that is the area you call A intersection C. Let's look at the next example. Now let's look at the region A only. As usual, we will need our Venn diagram of three intersecting sets. Now it is very important for us to know that A only means A without B and also without C. So let's locate the area within the Venn diagram that shows only A without B and without C. That is the area. It is the area that shows only A and it doesn't have anything to do with B or without B. It also does not have anything to do with C, without C. This area is the same as A intersection complement B intersection complement C. Complement B means without B and complement C means without C. So we have A intersection without B intersection without C. That is the same as only A. Let's look at the next example. Now let's look at the region B only. Let's first show our Venn diagram of three intersecting sets. Let's also note that B only means B without A and without C. So we will be looking for the area that shows only B without A and without C. That is the area. This region or area shows only B and it does not have anything to do with A, neither does it have something to do with C. This region is the same as A complement intersection B intersection C complement, which means that without A intersection B intersection without C. Let's look at the next example. Now let's look at C only. This is our Venn diagram. C only means C without A and without B. So let's represent this area or region on the Venn diagram. So that is the region. Only C without A and without B. This region is the same as A complement intersection B complement intersection C, which means that without A intersection without B intersection C. Let's look at the next example. Next, let's look at the region A intersection B intersection C. At this region, all the three sets A, B, C meet. First, we'll show our Venn diagram. We will now locate the region or area where all the three sets A, B, and C meet. That is the region. At this region, the set A, the set B, and the set C meet. So we call that region A intersection B intersection C. Let's look at the next example. For this example, we'll be looking at the region A intersection B intersection C, all into bracket complement. So let's first draw our Venn diagram of three intersecting sets. Now, let's note that to be able to find A intersection B intersection C complement, it is very important for us to be able to shade the region A intersection B intersection C. This is our region A intersection B intersection C. But of course, this region is not the same as A intersection B intersection C all into bracket complement. To be able to find the complement of this, all we need to do is to shade all the regions under the universal set without touching the area A intersection B intersection C. So let's quickly do this. Now this area shaded blue is the area A intersection B intersection C complement. As you can see, it is within the universal set, and at the same time it is outside A intersection B intersection C. Now let's shade the area A intersection B only. As usual, we show our Venn diagram of three intersecting sets. I will need us to note that A intersection B only means A intersection B without C. This is the same as A intersection B intersection C complement. This is the region that represents A intersection B only, or A intersection B intersection C complement. As you can see, at this region, it is only A and B that intersected. C was not included in the shading, so that's why it is A intersection B only, or A intersection B intersection C complement. C complement means without C. Let's look at the next example. In this example, we'll be looking at A intersection C only. And as you can remember, A intersection C only is also A intersection C without B. So we will first show our Venn diagram of three intersecting sets. First, let's remember that A intersection C only means A intersection B complement intersection C. Remember, B complement means without B. This shaded region represents A intersection B complement intersection C, which is the same as A intersection C only. As you can see from the screen, it is the region where only set A and set C intersected. You realize that B was not part of that intersection, so that is why it is A intersection C only and without B. Let's look at our next example. We will look at B intersection C only. So let's first show our Venn diagram of three intersecting sets. Let's also remember that B intersection C only is the same as B intersection C without A. This can be represented by A complement intersection B intersection C. Remember, A complement means without A. This is the region representing B intersection C only, or A complement intersection B intersection C. As you can see from the screen, at this region, it is only set B and set C that intersected. Set A was not part of that region, so that is why it is B intersection C only without A. Let's look at our next example. Now, let's look at the region A union B union C. First, let's show our Venn diagram of three intersecting sets. Let's also note that the word union means to unite. So A union B union C means we are joining the set A, B, and C together to form one unit. When we join the three sets together, you will get something like this. This region shaded blue is A union B union C. As you can see, it has joined all the three sets together to form a single unit. Let's look at our next example. For this example, we'll be looking at A union B union C into bracket complement. Let's first show our Venn diagram of three intersecting sets. Let's also note that to be able to find the region A union B union C complement, we will first need to identify A union B union C. This region represents A union B union C. But of course, that is not the same as A union B union C into bracket complement. To find A union B union C into bracket complement, we shade within the universal set outside of this red region. So let's quickly do that. So this is what we will get. The region shaded blue within the universal set outside of A union B union C is the answer, which is A union B union C into bracket complement. Let's look at our next example. For this example, we would identify an already shaded region. So we will be given this Venn diagram with the following region shaded. How do we identify this region? To do this, you will take the regions one after the other. So this is our first region. I believe you remember the name or notation of this region. This region is A or set A. I hope you remember this. Now, this is another region. I hope you remember the name or notation of this region. Well, it is the region B intersection C. As you can see, the two regions have been merged together. When two regions merge together to form a unit, they unite. In other words, they form a union with each other to form one unit. So, the region A and the region B intersection C would form a union. In other words, they will unite, and that would result in the formation of A union B into bracket B intersection C. It's as simple as that. Let's look at the next example. For this example, let's identify this region. As usual, we will be taking the regions bit by bit. Then afterwards, we would merge them together. So let's look at the first bit. So this is the first part of the region. This region is A intersection B, the point where the set A and the set B unite. This is the second part of the region. I believe you remember that this region is B intersection C. Now, this is the last part of the region. And I hope you remember that this region is A intersection C. As you can see, the three regions have been merged together to form one unit. So the three regions have formed a union. So the shaded region will be called A intersection B into bracket union B intersection C into bracket union A intersection C. It's as simple as that. Let's look at our next example. Now let's identify this region. As usual, you'll be taking the regions bit by bit, and afterwards we'll combine them together to get the region shaded on the screen. This is the first part of the shaded region. The notation for this region is A intersects B. This is the second region. Its notation is B intersection C. As we can see, the two regions merge together to form a single unit. So they form a union. So the shaded region is A intersect B into bracket union B intersection C into bracket. Let's look at the next example. Let's identify this shaded region. This is the first part of the shaded region. It is A intersection B. This is the second part. It is A intersection C. Now let's merge them to form a single unit. So we have a union of the two sections, and that is A intersection B into bracket union A intersection C into bracket. Let's look at the next example. Let's identify this region. This is the first part of the region. It is A complement intersection B. I believe you remember this. Now let's look at the second part. This is the second part, and it is A complement intersection C, which means C without A. Now the two regions will merge together to form a single region. In other words, they will form a union. This single region is A complement intersection B into bracket union A complement intersection C also into bracket. Let's look at the next example. Let's identify this shaded region from the Venn diagram. As usual, we'll be taking the regions bit by bit, and afterwards we'll merge the various bits together. So let's look at the first part of the region. This is the first part of the shaded region. I hope you remember its notation. Well, its notation is A intersection B complement. That is only A without B. Let's look at the second part. This is the second part of the shaded region. I believe you remember its notation too. Well, its notation is A complement intersection B. That is only B without A. Let's look at the final part of the shaded region. This is the final part of the shaded region. I believe you remember its notation. Well, its notation is C or set C. As you can see, the three regions have been merged together to form one unit. In other words, they have formed a union. So when they form a union, the notation for the shaded area will be A complement intersection B bracket, then union A complement intersection C bracket, then union set C. So that's the answer for this problem. Well, friends, part 5 of set and set operations would come to an end at this point. In our next meeting, we'll be looking at part 6 of the same topic. And in part 6, we'll be solving a few practical problems using Venn diagram, and here we'll focus on two intersecting set problems. Thanks very much for staying with us, and please subscribe for this channel if you have already not done that. We need your subscription for the continuation of this program. Also, once you subscribe and we make or come up with new videos, we will get you alerted. Thank you. Stay safe until we meet again in the next video.